Okay, my friends, so we got to figure out the radius of Bachelor, and I've Googled this all over the place, and I can't find it. So one thing, I had an idea, and I figured we could do this together. If we go to Google Maps, I discovered something recently on Google Maps that's pretty cool. So if you're in Google Maps, you can just look for Mount Bachelor. Okay, and it'll take you over there. There we are, Mount Bachelor. I'm going to try to center it up here so we can look at it better. All right, here she goes. Now, it's going to be helpful to see what it looks like. So I'm going to put the satellite image on. That's Bachelor. Now, you got to be careful. At first, when you look at this, you might think, oh, there's the mountain right there. And that's part of the mountain. But then you got to look back. Let's go back and look at the picture of Mount Bachelor. And you might notice, let's look at some images. This is a good shot, I think. Yeah, it's from their webpage. We'll look at that one right there. There, that's a gorgeous picture, actually. So the part in Google Maps here that you're seeing, now this was taken in summer, just so you know. You can tell because there's very little snow on the mountain right now. This part you're looking at here is this part up here. It's the part that's not treed, above tree line. So you can't just use the Google Map. This part would not be the full mountain. The full mountain runs down pretty far. Now I'm going to go back to this picture over here. Oh, I lost it. Where did it go? Oh, goodness. Oh, there it is. Oh, okay. So notice that if you're looking at this cone, it drops away, continues to drop away past into the tree line. Then it has this little hump here. This is actually called the cone, the cinder cone. And then it continues to go. So actually, if you think about, the sides of this mountain going down, where does it actually flatten out? I mean, hell, this is Qual Butte back here, and it actually technically goes even further than Qual Butte. So what we have to kind of figure out is, if you assume this is the tippy top of the mountain, so that right there is this part here. I'm not sure what those numbered things are on the map. That's kind of fun. Never noticed those before. Doesn't really matter. Those might be chair lifts or runs or something. If this is the top of the mountain, then the edge would actually run all the way down, say, past the cone. Now, the cone is a little tricky. I'm going to have to pull out a little bit here. The cinder cone that you just saw there is actually out here. I mean, that thing right there is this hump over here. So you're beginning to see just how massive this mountain actually is. And you can kind of tell because these ski runs are still on the mountain. So theoretically, realistically speaking, not theoretically, but realistically, this road cuts across Mount Bachelor. So I think a radius would actually be something like this far. I mean, if we think that the cinder cone here is about 2/3 of the way down the side of the mountain, and the mountain keeps going, then the radius probably comes all the way out to about here. Now, here's where Google Maps is kind of cool. If you're on a PC, you can actually right-click anywhere on a map and hit Measure Distance, and then it will actually allow you to click somewhere else. I'm going to click over here. This is about, I think, where you can argue that it flattens out. And that tells you just about how far away that point is down the mountain. So it goes down about 2.52 miles. This gives you an idea of how massive this mountain is. It's 2.5 miles from the summit to where the mountain would actually start to level off. Now, granted, it's not perfectly that. It's a rough estimate, 2.5 miles. You might actually consider it to be more like 2.4 or 2.6, depending on where you stop at. But you know what? I'll just use 2.4. We'll use 2.4 as the mileage. In the next video, we're going to talk about how to turn that 2.4 into the radius. Okay, my friends, so now we've figured out something about Mount Bachelor. I'm not going to draw the entire mountain because we don't have to draw the entire mountain. We just kind of need half of it to find the radius because the radius starts in the center and goes halfway out. So if you imagine Bachelor from the top as a big cone with a circle, it's coming out this way. It's three-dimensional. The radius is going to be that distance right there. Now here's the challenge. The challenge is the distance we just got, that 2.4 miles. If this is the summit of Bachelor, that 2.4 miles where it goes down. Where it goes down and hits the flat part of Central Oregon that it hits, is actually not the radius. The radius is down here. That's the radius. This is the height that you found back in the previous question. I'm going to go look that up again real quick because I have forgotten what that distance is already. That is 3,365 feet. So you can see right away, this is a very interesting problem because that's in feet, that's in miles, and this is what we actually have to find. So I think what we're going to have to do now is, well, first thing I think we need to convert one of these units to the other unit. And I believe, if I may suggest, I think we should convert that one to feet. Because eventually we want to get this thing in cubic feet, which means I think we should start with feet and not miles. So I think we're going to start by converting 2.4 miles into a number of feet. Now I know there are 5,280 feet in 1 mile. So to get 2.4 miles into feet, I do 2.4 miles times 5,280 feet per 1 mile. And I can cross off, where's my cancellation chalk? Here it is. Cross off the miles, and I can't do that in my head, so I'm going to let the math, I did it here. 12,672 feet. 12,672 feet. Now, the interesting part about all this, of course, is that this is a right triangle. Assuming that this is the height and this is the radius, when you Googled the formula for a cone, you saw that the height and the radius are perpendicular to each other. That means we can solve this using Pythagorean theorem. Just like we did with the building the fort, and just like we did with squaring up the room. It's a very useful formula. It shows up in a lot of places. Here's another place it shows up. What I'd like to show you now is a cool Google calculator that actually sets up the equation for you. This is a little bit different than the fort. In the fort, we knew this and needed to find this. This is a little bit different, and Google's got a fun calculator we can take a look at, and let's do that next and figure out what that radius is. Okay, my friends, so we've got the long side of the right triangle, the hypotenuse, and we've got the height, which is actually called one of the legs. So what I'm going to do right now is I'm going to Google Pythagorean theorem, and I spelled I spelled both of those words wrong, and somehow Google knew what I meant. Okay, so here's the cool part. Here's the triangle as A, B, and C. That looks like Mount Bachelor. A is the height, C is the distance down the slope, and B is the radius we need to find. So in other words, we're going to change this to solving for the hypotenuse to solving for the leg B. So we're telling the calculator to solve for that horizontal bit on the triangle. All we got to do now is tell it what the A and the C are. Now A, according to ours, is our height. So that's going to be the 3,365 feet. And the hypotenuse, which is that diagonal, is 12,672. And it's telling us that the radius, which we were looking for, is 12,217 feet. So that means that triangle is not drawn to scale at all. This is actually more to scale with the mountain. The diagonal distance down the mountain is about 4 times as long as the height. So there is your radius. We can actually call it about 12,000 feet if you want to just make life easy. All these measurements are very, very approximate in nature. So if you want to, just call it 12,000 feet and call it good. All right, now that you know that, move on to the next problem.